In this video, I'll show you how to wire the circuit up in order to measure the voltage transfer characteristics of a NAND2 gate available in IC7400. Shown here is the circuit diagram. IC7400 has 4 NAND gates that we can use. You place the IC as shown here with the notch circled in red pointing upwards, and you count from the left around all the way from 1 to pin number 14. We will use the NAND gate that is connected between pins 1, 2 and 3 for our experiment. Pins 1 and 2 are the inputs, 3 is the output. Place the breadboard on the table as shown in this figure. A breadboard is an array of connections where the horizontal pins are shorted in the fashion shown here, where the red, blue, yellow and green are shorted but not shorted to each other. Similarly, the vertical pins are also shorted as shown in red, blue, yellow and green, but again are not shorted to each other. This is how the final circuit should look on the breadboard. We will now tell you how to make each of these connections. We start with plugging in the IC. Plug in the IC as shown here with the notch pointing upwards. Also make sure there's enough clearance from the top for some wiring and routing. Pin 1 and pin 14 should be close to the far end of the breadboard as you face it. Make sure that you plug in the chip exactly around the center line, otherwise you will end up shorting the pins. Let us now look at connecting power and ground to this IC. In order to make a connection, you need a wire. So you take a wire and use a stripper to remove a part of the covering, not very long, not very short, but just right enough so that you can plug it into the breadboard. As a convention, we always use the red wire for VCC. In the case of the 74 series ICs, VCC is on the right top corner, and therefore we pick the right rail for VCC. Measure the wire so that it reaches the VCC rail. With some clearance, you can cut the wire as shown here in the video. And then strip off the other end so that you can plug it into the VCC rail as well. Note that since pin 14 is VCC in this chip, we are choosing the right end to be the VCC rail and the left end, which is closer to pin number 7, to be the ground rail. Note that the connection to pin number 14 is made through the neighboring horizontal pin, which, as I explained earlier, are all shorted. After making the connection, the wire and the chip should look like this. Similarly, you make another black wire connect the ground rail, which is on the left, to pin number 7. We will now look at how to make a probe wire connection. A probe is a metal object that is used to make contact with your circuit component in order to measure a voltage or a current. We need a very clean contact, and therefore we tell you how to make one. Strip the wire off and make sure you strip it significantly this time so that you can align the wire along the metal and rotate it as shown in this video here. Once you rotate it, you can cut the other end off long enough so that you can just about make the contact, and you strip the other end off to expose the metal so that you can insert it into the breadboard again. A trim pot is a 3-terminal device that allows you to obtain a fixed resistance R across the extreme terminals, and you can tap out the intermediate terminal with respect to one of the extreme terminals to obtain a variable resistance R1. The value of R1 can be tuned by adjusting the screw that is shown here. Before you start the experiment, you have to test the trim pot. You place the trim pot on the breadboard as shown here. Is this right? Well, definitely not, because the horizontal pins are all shorted. So you place the trim pot as shown here vertically, and now we will connect some probe wires in order to measure the resistance across the extreme terminals. So you make one probe wire on the red probe as shown here and connect it to one of the extreme terminals. Take another probe wire on the other probe and connect it to the extreme terminal, which should be 2 pins away. So as shown here, we have connected the red probe and the black probe to pin 1 and pin 3 of the trim pot. The other end will now go to a multimeter. Shown here is a typical multimeter that we will use in the lab. Multimeter can be used to measure voltages, currents, resistances of different ranges, and it can also be used to measure DC and AC quantities. So we have to configure this multimeter in order to read the right value. In our case, we are going to measure the resistance of this trim pot, and therefore we connect the red probe to the voltage node here and the black probe to the common or the ground probe there. We have to turn on the multimeter and configure it in the ohms or the resistance mode. Clearly you can see that the multimeter reads a value of 0.983 kilo ohms, which is approximately 1 kilo ohm, and the trim pot is designed to be 1 kilo ohm. We now connect the multimeter between the intermediate terminal and one of the extreme terminals. So we move the blue connection to the neighboring pin, thereby connecting the multimeter between the variable resistance and one extreme. So clearly you can see that it is reading a value of 108 ohms. This value can easily be changed by adjusting the screw. Turning it anti-clockwise causes the resistance to go up steadily, and turning it clockwise will cause it to come down. Connect one end of the trim pot to VCC, the other end to ground, and the intermediate terminal to pin 2 of the IC. The red wire is used to connect the top terminal to VCC, black wire to ground, and yellow to pin 2. We now show you how to connect pin 1 of the IC to VCC. Since pin 1 is being connected to VCC, we make use of a red wire. As usual, we take a piece of wire, strip off one end and plug it in to pin number 1. We then make a measurement so that it can just about reach the VCC rail, and then we bend it and we push it in and make a very firm connection with the VCC rail. Make sure that you do not use any other color of wire to connect pin number 1 to VCC. The VCC rail is shorted because it is along that vertical set of pins, and therefore I can connect these red wires to any of these vertical pins. We now show you how to connect a voltmeter between pin 2 and ground. In order to read voltages, you have to configure the voltmeter in the DC voltage mode as shown here. To connect the voltmeter across two terminals, you make 2 probe wires as shown here in green and blue. We connect the green probe to ground and the blue probe to pin number 2. Similarly, you have to connect another voltmeter between pin 3 of the IC and ground as shown in this circuit diagram. Before we start the experiment, we have to ensure that there is continuity in all the connections that we made. In short, we have to ensure that all the connections have the right effect at the respective pins. You can configure the multimeter to go into the continuity mode by switching the knob to point to this diode. Of course, what we want is the other end of the knob which points to this audio signal. And for that, we have to press the function key. And on the screen, you will see this audio signal appear, which indicates that the multimeter is in the continuity mode. Now, when you just touch the two probes together, you will hear a beep, which indicates that there is a low resistance path between these two terminals. In order to configure it in this mode, make sure that the probes red and black are connected to the volt or ohm and the common ground respectively. Now we want to ensure that VCC and ground rails are connected to the appropriate pins, namely pin 14 and 7, and pin 1 is also connected to the VCC rail as shown here. We first test continuity with the VCC rail. So we connect a black probe to the VCC rail, and the other probe is now connected to one of the pins. So pin 1, for example, shows continuity with VCC. Make sure you always connect and contact the pin directly. Now we switch the probe to pin number 14, and again a beep indicates continuity to the VCC rail. Switching to connectivity test of the ground rail, we connect one probe to the ground rail and make contact with pin number 7 using the other probe, and a beep there ensures connectivity to the ground rail. With that, we have shown how to build a circuit using a breadboard by inserting a chip, making probe wires, testing a trim pot, and making sure that connectivity is correct across all the key connections.